Hello and welcome, everyone. My name is Justin Bauman. I'm a specialist solutions architect here at Red Hat, and today we're going to be looking at the OpenShift Developer Experience along with CodeReady Workspaces, which is, a cloud-native approach to development. To get us started, I'm just going to walk us through a quick slide deck here, where we can just outline sort of the challenges that led us to, really the features of OpenShift's Developer Experience and CodeReady. So to get started, let's look at what local development, presents as a challenge today. And in local development, it's a challenge because the complete tooling required on every developer machine is a challenge to maintain. It's a challenge to maintain that configuration. Other alternatives to localized development, like using like a VDI solution or virtual machines, also prevents some challenges because there could potentially be some network latency, or of course the classic limitations of, developers aren't necessarily local administrators, or they don't necessarily have the freedom or flexibility to choose different tools. So what may end up happening is they end up working on their personal machine or another laptop with source code, which presents a potential vulnerability. If that laptop were to get lost, someone may access, that source code and have, access to certain secrets. But also from a more of an insights perspective, some of the things that's really challenging today in development is once we do deploy a containerized application to wherever it may be deployed, it's really difficult to get the logs and information from it. So we don't really have a lot of insights as developers around what exactly is going on with our application. It's very difficult to debug or test issues in production when you have to be retroactive. And also having self-service to be able to, either service the infrastructure and dependencies that your app relies on. So a lot of these things become a challenge when it comes from the local development side. And that's really why we have put this all together in the OpenShift Developer Experience, is to make sure that we can address all these issues. And we're going to see that once we jump into the demo. Now next, we just have a customer success story. Previously, before moving to a cloud-native development solution, it was taking them a considerable amount of time to onboard new developers. It was a challenge to get them up to speed with the existing technologies in use, architecturally, how all those applications fit together. And so to avoid all that, moving to CodeReady Workspaces gives you instant provisioning of environments and workspaces for developers to work in. They are, they're running as containers specifically. So they're ephemeral. They're not meant to live forever. It's a workspace that's just there for when you need it. And it really makes it easy to reproduce. And we're actually going to see that here in the next slide. So when it comes to laptop-based development versus CodeReady Workspaces, there's a lot of parity here between them. But of course, on the laptop side, like I was mentioning earlier, the challenge is to share consistency. So all the main dependencies of running an application, so the runtime tools, SDKs, web servers, operating system specific stuff, databases, all that stuff is really difficult to replicate in traditional development. But in CodeReady Workspaces, we take a declarative approach where we get to declare configuration files that will get applied as developer workspaces. So we're able to deploy all the dependencies, such as databases, web servers, logging servers, really whatever it may be, we can have those things packaged as a configuration and have it deployed as a usable coding workspace for any developer. This is going to sort of lead us into the next bit here, which is specifically about CodeReady Workspaces and the benefits that you're getting here. On top of what I already mentioned, you have technical governance. So, from an operational perspective, we still have the ability to control certain tech stacks to make sure that developers are using tools that are only approved by the organization, but in other environments, giving them some freedom to work with those dev files directly. And we'll see how that works once we get into OpenShift's demo. It's also going to give you that one-click provisioning, so you can have workspaces on the fly, ready for your developers. And the idea here is to really reduce the "it works on my machine." Since all this is going to be running in containers, it's all reproducible. And those environments are dynamic based on configuration. So this is a browser-driven developer experience where you have access to all the same features that you do in local development, debugging, having terminal access, being able to work with those applications and resources in real time. multiple monitor support, and because we're using this container-based approach to this, like as I mentioned, you can deploy all those dependencies within that workspace, thanks to a lot of the developer features that are made available to us through OpenShift. And we're going to see those here shortly. Now, before we jump into the demo, just a quick sort of a preface to what we're going to look at. We're going to be focusing primarily on the developer experience within OpenShift, and there's two primary consoles, an administrative side and a developer side. So today we're going to be focusing primarily on the developer's perspective and what that offers us. So without further ado, let's get into the demo. So as we're moving into the demo, looks like I lost my demo. That's fine. We can get that spun up quickly here. Okay. So I'm going to go ahead and get logged into my platform. So this is me accessing the OpenShift platform here. And as you may have noticed, I have it set up with my Active Directory, so that way my user authentication process is seamless throughout the organization. And we've now landed in the developer view within OpenShift. And specifically, what we're seeing here is the topology view. So this is really the most helpful and sort of the center point of what OpenShift's developer perspective is going to offer us. So essentially, it's going to give us a visual representation of how our apps look. And it gives us a lot of visual connections so that we can show how the application's flow works as well. So again, working really well to help onboard developers who are new to the project so they can understand what the application is. And in our instance here today that we're going to be working with, I just have a basic 3-tier .NET Core application. So we have a user interface, an API, and a database. And the data flow works approximately like these visual connectors are showing. So now, what else I want to look at here is, the project itself that we're looking at. So within OpenShift, we're working primarily with projects, which is equivalent to a Kubernetes namespace. And with this Kubernetes namespace or project here in OpenShift, we can, this is how we're going to separate or isolate our workloads. In my particular instance, I've got a dev and a test environment here, so I can have some parity between, and good for release planning. And now other options available to us here within the project in the developer view is we have a project dashboard. So here's where we get to have a really high level view of what's going on in our little world here for our application. So we can see the resources that our applications are consuming. We can see the inventory of what's actually deployed. You can see there's a number of deployments, a number of active pods, storage services. So OpenShift's taking care of all that for us. And we're actually going to walk through what that process looks like here shortly. And it also gives us an activity log of all the events that are coming out of OpenShift as well. And also, we have the ability to configure the project access. So when you create a project in OpenShift, you become the administrator. So as a developer, if I'm working on a new project, I'm the admin. I can go ahead and add access for other folks. And this is based on our role-based access control in OpenShift. So it's highly configurable. So you can change really how developers are able to interact with OpenShift. So moving along here, we have some integrated CI/CD solutions, and we're going to be looking at a few of these today. So this OpenShift Pipelines is built on Tekton, and essentially this is providing us a container native way or a Kubernetes native way to construct and build our applications. Basically taking everything, running everything in individual tasks, and letting us get really granular with what that looks like, and also giving us the ability to make these tasks reusable. So they're not just limited to the project that we're developing them in. We can potentially make them for the cluster so that all developers can share them. So from both an operations perspective and a developer view, this is a really robust pipeline to build your applications and get them into OpenShift with the tight integration that there is. Now also here we have config maps and secrets. This is where we're going to store all of our secrets that we can inject into our applications later as environment variables. And we'll see what that looks like here shortly. And then lastly, we have our monitoring tab where we can get a little bit more granular about what's actually going on within our application and our project, and even scoping it down to specific workloads. So if I jump back here to the topology view, so we have our application, but I want to go ahead and create a new environment. So we're going to go ahead and create a project, and I really am in need of a QA environment. or we can really test this before we end up releasing. So now that I have a new project created, you can see that there's no resources here in our topology view. So we can either right-click here and add to project and use this context menu, or we can just go to the add page, alternately hitting the button over here in the nav. And this is going to provide us, and specifically developers just coming to the platform, really robust options to get started. So there's plenty of getting started resources here, but also it's going to show us primary deployment mechanisms to get things and applications into OpenShift. So we can choose from a service catalog that can be maintained by the operations folks or even the developers themselves. We're going to actually look at that here shortly. Or we can deploy directly from our source code and then have OpenShift use a builder image to create a running application from our source code. We also have the option to deploy from a Docker file. So we're probably pretty familiar with that. We can define that process in our source and then have OpenShift use that to build our application. And then also we have to build from a dev file. So this dev file, we started to talk about some of that technical governance aspect in CodeReady Workspaces. The dev file is the declarative approach to creating these workspaces. So we can even do it from that as well. Or we can use existing container images that were potentially built off platform or on. And of course, we can import templates of YAML. And we can even, as we're getting more features rolled out here, we can even just start to take our applications and drag and drop them into the OpenShift's topology view. Right now we have support for Java applications. Just drag them in there, and it's going to automatically get created as a running container. So there's a lot of options here before us, but before we get into deploying our test app and getting staged for today, I just want to take a quick look at the developer catalog. So I mentioned builder images. There's also templates, and there's a number of resources. This is like an a la carte menu for really a whole bunch of reusable things. So the builder images basically are container images that have the knowledge on how to take some source code for a specific language and turn it into a running application. So that's what we use for the source to image process in OpenShift. And now we also have templates as well. And these templates are basically a way for us to make a process reusable and parameterize it. And then OpenShift will generate a user interface for us so we can fill out the correct arguments to deploy a certain piece of software. And we're actually going to see that when I stage my applications, because I'm going to be in need of a database. But one last thing here too is from an operator perspective. We didn't really cover that much in this session, but operators on OpenShift are essentially just pieces of software that know how to deploy and maintain the lifecycle of other applications. So from an operations perspective, once we add operators to the platform and install them, we have, as developers, the option to use a lot of those resources. So you'll see the operator backed category. So in my instance, I have Ansible automation platform on here, just as an example. So as a developer, if I needed to deploy a automation job, I can use this because of the operator that's installed. But to get us staged up for what we want to do today, so we have our blank canvas, and I want to go ahead and get my 3-tier application deployed here. And then we can work on the source code inside of CodeReady Workspaces. And again, we're doing all that development on the platform. So my source is never leaving a secured environment. So I'm going to go ahead and go to add the project, and we are going to add a database. And that's going to take us back to our dev catalog, and we're going to choose the Mongo database. And this is just going to instantiate a template. And you can see that this template has a few things defined here on the right-hand side. Basically, it's going to make a deployment in OpenShift. It's going to go ahead and set up the storage, and it's going to create the secrets and the networking layers. And now here on the left-hand side are the parameters that we can pass over to it. And so in my instance, I follow a certain convention, so I will continue to follow that with my naming scheme here. So we'll give the database a name, give it a default database name for my application. And some of these other things like the connection, usernames, and passwords, we could provide those if we want. But if we leave them empty, OpenShift will automatically generate those as secrets that we can consume in our apps. And we're going to see that here. So I'm going to go ahead and create my deployment of Mongo. And now that we have this in progress of spinning up, I'm going to go ahead and get the other two components here spun up as well. So we're also going to build from a Docker file. And I've got the options to just directly import my application. We're actually going to be the UI on this one. So this is a private Git repo, so we have to add some credentials. So I can go ahead and add in a secret here and punch in my Git credentials. Go ahead and create that. So now we should be able to authenticate to that repository. I'm specifying where my Docker file lives, and I'm going to make an arbitrary or like a logical application grouping. And my app name is just .NET UI. And we're going to use OpenShift Pipelines, where if we didn't, it would just use the source to image process of OpenShift builds. We can actually visualize that before we build. And we're going to create the networking layer. So we're going to actually add routing to our application. So I'm going to go ahead and create that. And we can see here that it's created our new resource. There's a few useful icons on here. There's a quick launch to the route that we provided, well, that OpenShift generated for us. But we also have the current status of our build process. So this is that integrated solution here in OpenShift. And this is essentially, we can look at the details. There's individual tasks that'll be running in separate containers to basically fetch our code, build the code into a container image, and go ahead and deploy that to OpenShift. And this should look pretty familiar, like other CI solutions out there, where we're going to see a step-by-step here on the side, and then see the output of what that task was. So let's go ahead and jump back here to the topology view, and we're going to go ahead and add our last piece here, which is going to use source to image. So we're bringing in our API, and I'm going to go ahead and use that existing secret. I'm using a .NET application. We'll select the proper version for my runtime. I'm going to go ahead and put it into that logical grouping, and we've got our unique name here. And now we can go ahead and add that pipeline as well, create that. Again, most of the defaults here are going to work fine for me. We can also shift-click things into the arbitrary groupings. So there we are. We have our application grouping, and we have the visual connectors where we can go ahead and outline what our application is going to be doing. So now also, if we click on this deployment here, we're going to see all the details about it. So we have abilities to add health checks, which highly encourages that you do, where we can have custom lifecycle hooks into our application in different stages. Essentially the ability to add probes to check if our application should be receiving network traffic or if it's not ready yet. Also ones to make sure that the application's still running, and then one that starts that'll get executed once when the container is started initially. So any lifecycle checks that we need to be doing, we can do those through the health checks to ensure that our application lifecycle is a bit tighter and better maintained. And we can choose from a number of different options here for deployments. We can either do web requests, container exec commands, or even just checking if a port is listening. So outside of that health checks there, we also have options here to immediately add in horizontal scaling for our application. So we can just add in a horizontal autoscaler here. We can add in storage. We can change our update strategies, resource limitations. Really the possibilities are endless. And now I'm going to go ahead and jump over to my pre-baked one. Let's jump back to my dev environment. And so I've got my UI, my API, and my Mongo database. And I just wanted to quickly point out, like I mentioned earlier, we have access to things that traditionally, once we've deployed this app, we don't. So if I wanted to, I can just directly see what the application logs are doing. So again, capturing that standard output. But also if I need to debug or maybe test a fix or a feature, we also have direct terminal access to the running pod as well. So if we need to run some commands to evaluate something, we can certainly do that here as well. And also everything in OpenShift is going to be backed by YAML, so we can always get the YAML representation, and you can really see what's actually going on under the covers with OpenShift and what it's providing you. So if we jump back here to the topology view, I just want to quickly show how we can actually network these applications together, because that's kind of the important bit that is traditionally challenging as well as for development. So we're going to be using the OpenShift service networking model here. So essentially we have a service that gets deployed that's only internal to the platform network. And that's going to be specifying our port mapping. And this service name, the reason that the application name and service name need to be unique is because it's DNS routable. So we're actually going to be able to directly use these names here to interface with our applications. So if we go in here and we go to edit this application, edit the deployment, and scroll down, we can see the environment variables section. So I need to be able to wire up my user interface to communicate with the API. So I've set up some environment variables inside of my application. So that way I can just let it know where to connect. And the notation here is we could just do the .NET API. That will work. We can also do the full notation, which is we're going to add a dot in here, and we're going to use the namespace name. Now, if we used another namespace there, like our QA one that we just created, this user interface from dev would effectively be communicating to the QA service. So, lots of flexibility here in this full notation. It makes it pretty easy to make sure you're hitting the right service. And I'll throw the port number on there as well. And then lastly, we just want to throw on a version tag. So my application needs to know which API to hit. We're going to hit the version 1. We're going to go ahead and save that. And now we can actually see our application doing a blue-green deployment here. It worked pretty fast. But essentially it took away the old one and started rerouting the network traffic to our new instance. And once everything was set and complete, it took the old one away. So now we have our latest running service. If we actually launch this application, we can see I programmed in here a connectivity status. Now that I've added that in, we can see that we are hitting the API, but the API can't hit the database. So let's go ahead and fix that problem. So we can come into here and do the same process. But here's where we're actually going to be injecting those secrets into our application. So we need a number of bits here. So we're going to have to put in the name of our database. So this is that service name. And I'm going to do the more qualified name here. Make sure we're connecting to the right instance. Go ahead and add another one here for our port number. And essentially what we can do here now, we can import also from resources available to us. This is what I was saying with injecting secrets and configuration maps. So we even have the option here, as a developer, again, I didn't really care about what my Mongo database username or password was. My application does. So let's go ahead and if we just import our secret here, we can select what key to use from it. So we need our database user. We need to get the username, or the password rather. So we go ahead and add that in. And then lastly, we have our port user. We also need the database name. So I'm going to go ahead and just add that last secret in. So if we just do .NET Mongo here, this is that secret creator from my template. We'll go ahead and use the default database name, admin password, and user. So we're looking like we're wired up. Let's go ahead and save that. Again, it's going to just quickly flip our deployment. And if we can just go back to our user interface and go ahead and reload. And once that connection is made, there we have it. The database is now communicating with the Mongo database. Or no, the API is now communicating with the Mongo database. And if we want to see that in real time, we can actually view the pod logs. And again, because I've got a lot of standard output being put here. And we can see that it validates that by calling a DB ping. And it uses our connection string, gets built in from our secrets and environment variables, and then evaluates that it can connect. And now we, at this point, we have a functioning application process here. Everything is set up and ready to go. Now let's jump into CodeReady Workspaces. So this is where we're actually going to be doing the development of our application. So we just go up here. We can any Red Hat supported operator is going to appear here in this list if it has a user interface. So we can just navigate directly to our CodeReady Workspaces. Alternatively, we could hit, because these deployments know where our source code lives, we could hit this button here, and that will automatically take us to CodeReady with our source code. So lots of fast path options here, but let's go ahead and just go in through the normal interface. And so now we're inside of CodeReady Workspaces, and we're going to be ready to work on our code. So you can see I have an existing workspace here, so we can have as many workspaces as we want, with limits set on how many you can have actively running at a given time by the operator. And if I wanted to create a new workspace, here's that technical governance again, where my organization was able to set up all these different dev stacks using dev files in the registry to be able to specify what I can and can't do. So I can choose these templates to get started. Of course, I can also import one from a Git repo, or I can create a custom workspace. This is all configurable through our access control. But if you actually look at what a dev file is doing, we're just declaratively writing up what components are dependent on. So we have IntelliSense, we have a plugin for live debugging on our breakpoints. We have the actual runtime image with the .NET SDK. And we actually have the source of where our project's going to be coming from, which could be Git or a zip repo. And we have commands. There's a number of things that you can do with the dev files, and you can even have this, to basically set up all the dependencies. So you could have this deploy databases, web servers alongside your development environment, and what have you. So let's go ahead and jump back to the quick add here. And actually, I'm just going to go ahead and start my existing workspace, since I already have it imported for my API code. Alternatively, I could have just hit this button here and immediately jump into it. And while this workspace is starting up, we can see inside of OpenShift what it's actually doing. So part of that default strategy is just to use my username and suffix that with CodeReady. So if we jump into this project, we can see that we're creating a deployment here. There we are. I was actually a little too early. So you can see that we're creating a deployment here. And this deployment is going to consist of a number of resources. So it creates a lot of services for us in our networking layer, creates a lot of routes to make this developer experience as seamless as possible. And if we view the logs, again, we can see all the different containers that are running and working together in tandem. Okay, now that our workspace is all started up, let's go ahead and jump back over to the actual workspace itself. We're going to see this management layer disappear, and our workspace will be ready to work on. And then as a developer, this should look pretty familiar from here on out. So we're going to have, our actual developer environment here that we can work in. So we can write our code. And like I mentioned, there's plugins so that the IntelliSense will work and our code, auto completes and whatnot. We have our source control over here as well. Very similar to VS Code. Interoperates with VS Code plugins as well. And so we have our options here to, basically go through all of our code, work as we normally do in development if we want to, make multiple tabs of this and work on many monitors like I mentioned earlier. We also have over here, we can see the different connections and endpoints available to us, the Workspace Explorer as well. We can see all those different commands and components that we were defined in the dev file. So with this, I can update my dependencies, run a build, or I can even run my application. So since my application is already built here, I'm going to go ahead and just hit the run option. So this is going to execute that command, and we're going to basically just say, ask the CLI tools to run my app. And now CodeReady Workspaces is letting us know that, hey, there's a new process listening here. Do you want to make it available? Let's go ahead and do that. And if we open that link, we can either open it in a new tab, or work with it directly inside of the workspace. And this is an API, so we're going to have to call an endpoint if we want to see some data. So I can go ahead and call one of those health endpoints, and we're just going to call the ping API. There we are. So we're able to work with our applications in real time inside of the CodeReady Workspaces. We can also debug and attach to the existing process should we want to. Again, that's just for the breakpoint checking. And we get our standard output down here as well. And so from here, whether you're comfortable or not working with containers as a developer, you really don't have to worry about that. So even if you're new to containers, if you're working in CodeReady Workspaces, your applications are already running in containers. So my .NET app here is completely running inside of a container housed within CodeReady Workspaces and the actual workspace that got stood up. And so from here, there's plenty of other options that we could explore, but I think this is all the time that we have for today's session. But essentially, actually, we're going to do one more thing here, and that's going to be just pushing a code change up, so we can just see what that looks like. I mentioned, we talked a little bit about the OpenShift pipelines, so let's just go ahead and stage a change, because I have OpenShift set up with a webhook to my source control. So that if I stage my changes and commit them, it's going to automatically kick off a build for us in OpenShift. So if we go ahead and push, again, private Git repo is going to ask for my credentials. We'll go ahead and enter those in. And once we've successfully pushed, if we go back over to OpenShift and we go back to our environment that we were working in, let's see, I had that integration built in the prod version. So we can see I've got a listener here, and we can get more into that in another session. But essentially, there's a listener that's going to listen for that webhook and it's going to automatically trigger the pipeline for us. We can see that we have another pipeline in progress, another pipeline build. And then from here, the latest version of our application will get pushed out. And like we saw with the blue-green, it's going to automatically flip that over to the new version, and it's as if nothing ever happened. So I hope you all enjoyed the content for today. And we will be doing another session here soon on more for CodeReady Workspaces and the developer experience. Thank you.